Dear viewers, in this session we shall discuss regarding valence and oxidation number. Generally, students may get confused regarding valence and oxidation numbers, and they write both the words as synonymous words. Let us see what are those. So, before going to know regarding valence, let me discuss what the valence shell is. In an element, the outermost shell is called valence shell, and the electrons which are there in the outermost shell are called valence electrons. So, valence means the combining capacity of an element. The combining capacity of an element with other elements when it forms a compound. Then what the oxidation number is? The charge possessed by an atom in a molecule in order to form a chemical bond with another atom. This is due to the loss or gain of electrons. This takes place due to the electronegativity difference between the combining atoms. Now, oxidation number and oxidation state, these words generally used by students. So, oxidation number means it may be a whole number either positive or negative charged, whereas oxidation state may be a whole number or 0 or fractional. Let me discuss regarding the differences between valence and oxidation states. The first difference, if we observe, valence simply tells the number of bonds an atom can form, whereas oxidation state gives information how many electrons have lost or gained in the formation of a bond. In the case of second difference, valence tells the number of bonds needed to make the stable compound, whereas oxidation state tells in the formation of a stable compound the number of electrons lost or gained. And the third difference is valence is a whole number, it has no charges, whereas the oxidation state can have a charge as well as a 0 or a fractional. These are the differences between valence and oxidation states. Now, let me define what the valence is. Valence can be defined with respect of hydrogen atom or chlorine atom or oxygen atom. So, valence is the number of hydrogen atoms or chlorine atoms or twice the number of oxygen atoms with which an atom of the element combine is called its valence. Valence with reference to hydrogen atom. So, valence of chlorine in HCl is 1, that means one chlorine is combining with one hydrogen atom, and valence of sulfur in H2S is 2, that means one sulfur is combining with 2 hydrogen atoms. In the same way, valence of nitrogen in ammonia is 3, and valence of carbon in methane CH4 molecule is 4. And then valence with reference to chlorine atom. So, valence of sodium in NaCl is 1, that means one sodium is combining with one chlorine atom, and then valence of magnesium in MgCl2 is 2, that means magnesium is combining with 2 chlorine atoms. In the same way, valence of aluminum in AlCl3 is 3, and valence of carbon in CCl4 is 4. Then valence with reference to oxygen, it is twice the number of oxygen atoms with which an element can combine. So, valence of hydrogen in H2O is 1, That means one oxygen is combining with two hydrogens, and then valence of sodium in sodium oxide is also 1. Here one oxygen is combining with two sodiums, or two sodiums are combining with one oxygen atom. So, sodium's valency in this molecule is 1. In the same way, in MgO valence of magnesium is 2, and in AlCl3 valence of aluminum is 3, and valence of carbon in carbon dioxide is 4, and valence of nitrogen in N2O5 is 5. Then the variation of valence in a group and a period. Regarding variation of valence within a group, as we move down in a group, the number of valence electrons does not change. So, all the elements of one group have the same valence, whereas variation of valence within a period, while moving across a period, the number of valence electrons of elements increases and varies between 1 to 8, but the valence of elements when combined with hydrogen first increases from 1 to 4, then it reduces to 0, and when combined with oxygen or chlorine, the valence of elements increases from 1 to 0, and sometimes it may be up to 0. Then variation of valence in a period is given in a tabular form. So, groups 1, 2, 13, 14, 15, 16, 17 and 18, and in first group the number of valence electrons is 1, in second group it is 2, 13th group it is 3, 14th group 4, 15th group 5, 16th group 6, 17th group 7, and in 18th group 8 valence electrons are present, and valence increases from 1 to 8. Then valence as per hydrogen scale, if we observe, so it increases from 1 to 4 and decreases to 0. Examples are given, some hydrides are taken here. So, in the case of sodium hydride, sodium belongs to first A group. So, it has one valence electron. So, its valence is 1. In MgH2 magnesium hydride, which is second group, magnesium is second group element. In MgH2 magnesium has valence 2. In aluminum hydride, valence of aluminum is 3. In silicon hydride SiH4, valence of silicon is 4. In phosphine pH3, valence of phosphorus is 3, and in H2S hydrogen sulfide, valence of sulfur is 2, and in HCl valence of chlorine is 1. That means, as per the hydrogen scale, valence first increases from 1 to 4 and then decreases to 1. Then valence as per the oxygen scale, so it increases from 1 to 7. Examples of some oxides taken place here. So, in sodium peroxide or in sodium oxide, Na2O, valence of sodium is 1. In magnesium oxide, valence of magnesium is 2. In the same way, in Al2O3, valence of aluminum is 3. In SiO2, it is 4. In P2O5, valence of phosphorus is 5. In SO3, valence of sulfur is 6, and in Cl2O7, valence of chlorine is 7. Then some commonly observed oxidation numbers, here a set of rules are there, we shall discuss regarding them. So, rule 1, all elements in uncombined state, that is helium, nitrogen, oxygen etc., will have 0 oxidation state, and then all monoatomic ions, that means H plus, Na plus, F minus, Cl minus, Br minus etc., their oxidation state is same as their charge, and hydrogen in all compounds exhibits +1 oxidation state. But in metallic hydrides like sodium hydride, magnesium hydride, calcium hydride, etc., it exhibits -1 oxidation state. This is because the electronegativity difference of hydrogen is more than metals in their metallic hydrides, and oxygen in all compounds exhibits -2 oxidation states, but in the case of peroxides it exhibits -1 oxidation state. Example, hydrogen peroxide, sodium peroxide, barium peroxides, etc. In all the peroxides, oxygen exhibits -1 oxidation number. In S block elements, oxidation number is equal to group number. That means all first A group elements, that is alkali metals, exhibit +1 oxidation state in their compounds, whereas in second A group elements, that is alkaline earth metals, they exhibit +2 oxidation state in their compounds. In the case of P block elements, the oxidation number varies in two ways. One is oxidation number is equal to group number, and second one, oxidation number is equal to 8 minus group number. Example, the oxidation number of phosphorus in PCl5 is +5, that is phosphorus is 5th A group element, so its oxidation number is +5, means it is equal to its group number. The second example, the oxidation number of phosphorus in PCl3 is +3, that means it indicates its oxidation number of phosphorus in PCl3 is equal to 8 minus group number, that means 8 minus 5 is equals to 3. Then in all the transition elements, they show variable oxidation states due to the presence of incompletely filled d orbitals. They show +2 oxidation state if they lose ns electrons. If they lose ns electrons, they show +2 oxidation state. If they lose n-1d electrons, they exhibit variable oxidation states like +3, +4, +5, +6, etc. In the case of F block elements, they show common oxidation state +3 in their compounds. Next, the important point that we have to note down here is the sum of oxidation numbers in a compound is 0. Example, H2O, H2SO4, HNO3, NaOH, AlOH taken thrice, etc. If you take H2O, the oxidation state of oxygen is -2, and oxidation state of hydrogen is +1 into 2 is equals to +2. So, +2 and -2 gets 0. That means the oxidation state of the compound is 0. The sum of oxidation numbers in a polyatomic ion is same as its charge. Example, in SO4 -2, CO3 2 minus and NH4 plus, etc., the total charge of SO4 2 minus is equal to its charge, that is -2. The total charge of carbonate ion CO3 -2 is its charge, that is -2. The total charge of NH4 plus ion is equals to +1, its charge. So, in this session we discussed regarding what the valence is and what is the oxidation number and what is oxidation state and the differences between those two terms and their variation in a period and in a group.